I am really excited to be here because I'm working on this demo that if the demo gods are with us today, will actually work. There's about a 5% chance that's going to happen. What I'm talking about is, can I get the slides, please? Thank you. Yeah, so I'm Juan. This is Arturo. Arturo's going to be coming up in a bit. This is going to be capturing the room. So this is a FARA device that we'll talk about in a little bit. So you will all be put into a 3D model that we're capturing. It's a laser. It's fancy, and I don't really understand it, but Arturo will talk about that in a little bit. So I work at Microsoft in the Azure IoT team, and I've been working on that team for about 3 years. And I've been working on device management, and then that led to device twin, and everyone said, "Oh, I know what that is. That's digital twin." And we said, "No, device twin is something else." But then I realized, wait a second, we need to figure out how device twin relates to digital twin. And so I started working on digital twin, and I learned a ton of stuff about where this came from. And it turns out it came from about 2002. There was a university, I can't remember exactly which one. I can send you the references and all that. That started working in the PLM space. And so around trying to deal with physical assets. And so PLM, if you don't know, is essentially product lifecycle management. And in PLM, you basically define a product, the stage, this room, this computer, and then you design the model of that product as a bill of materials, for example. And then you figure out, and then there's all these associated business processes, like where am I going to get the screen from, and where am I going to get, the keyboard, and all these things, right? And so there's some really interesting things about how that product is composed that later led to other government type of, like NASA and Air Force and Navy, to actually use this for the products that they were building. It's really hard difficult to iterate on a space shuttle or a jet. And so, and it turns out we know all the science. Well, not all the science. Yeah, we don't know all the science, but we know a lot of the science around physics and dynamics and thermodynamics, and we have a lot of modeling tools. And so that kind of led to being able to iterate in the physical world. And so we start off with this physical asset. So as I went on this journey, I essentially realized that digital twin was about modeling a physical asset through a virtual asset. That allows you to iterate on that thing instead of the other thing. So an example that I talk about when I talk about digital twin is, at some point in the future, I will send my car to the shop. And I will actually drive to work with my car and leave it at work and then drive home with my car, and my virtual car will go to the shop. And then they'll email me and say, "Hey, you know what? Your brakes are worn out. We just checked the virtual model of your car, and it turns out you need to get a different car." And then they'll bring me a different car or something like that. I don't know. But the point is, my car, I will not be bothered by the fact that I have to go. I'll just send the virtual version of it. So essentially, the physical asset itself has a physical interface and an environment, right? That car, this building, this computer is not operating in isolation. It's actually operating in this environment, and it has an interface. I can stand on the stage and so on. And so the environment has a model, the device has a model, and the physical interface can have a virtual interface. And one of the main things that I realized as I was going through this journey is that this stuff is not new, right? A lot of this stuff, we've been building software for a long, long time, with interfaces and with models. And so 2 points that I wanted to make is that this idea of digital twin is a progression, as I was realizing, and we actually have learned a lot about this before. So for example, if you think about line of business applications, we've been thinking about, even all the way down to something like Excel, right? We model things in Excel all the time. We're dealing with data. We're actually processing that data. And we have a user interface, we have a model, and we have business associated with it. Of course, business is what makes all this stuff possible, because if the business case is not penciled out, then we don't get to do all the other fun stuff, right? So we have this idea of a very simple line of business app is kind of a beginnings of a digital twin to a certain extent, or really a path towards the digital twin. And then on the other side of the coin, you have the idea of a physical interface, an environment, and the business. And this is something that I have not really been dealing with in my career up until now. So Arturo, for example, is an architect. He's been dealing with physical interface, environment, space, lighting, and things like that. And it turns out that as these two things come together, we get the idea of an interdisciplinary situation that is really, that when you connect it all up and you gather data from it, then it helps you iterate, but it also helps you justify the fact that you have a business problem and you're trying to find how to really make that business, optimize that business, or in the case of a nonprofit, maybe optimize the impact, for example. So where's the opportunity here, right? So that's, to me, at the end of the day, it's like, okay, well, this is neat, and these are some interesting concepts, but there's some pretty interesting opportunities. The interaction between user interface and physical interface is kind of an opportunity that is a relatively new concept, right? So we're going to show some things on stage today, and Arturo will talk about this a bit. And then from an environment and a model perspective, there's a really amazing opportunity to go out and model the world, right? It doesn't exist today. Today we have maps, they're 2D for the most part, 3D in some sense, but at some point London will have a fully digital version of London where you can actually figure out what, with traffic. I know that sounds insane, but it's only a matter of time, right? So there's, think of it like before the web, right? There was this opportunity to go and create websites for everyone. There's an opportunity to go create models. And if you have an asset, create a model of your thing and then share it, right? So that's an amazing, we're an amazing time here. And at the middle of all this stuff is IoT, because this model is in isolation. We have models today in isolation. But when you get models and you attach real-time data to them, and you attach batch processing data, and all these different interesting scenarios around IoT, remote monitoring, predictive maintenance, all this comes together in a really kind of a perfect storm. As I was, again, continuing my journey, I realized, wait a second, all these digital twins that I'm seeing from all these different companies and analysts are really complicated. I'm a developer. I want the hello world, right? So I want to figure out, how do I build one of these things? So this is where Arturo comes in. So at one point, I'm on Facebook. So this is the whole scan, Facebook, lunch, Connect, IoT, Unity, and Thingmonk. So there's a sequence here. So we were at lunch, and I had seen Arturo post something on Facebook, which was kind of amazing, because I didn't understand it, right? It was kind of magical. And so I said, hey, Arturo, what was that? And he said, oh, I just scanned my apartment, and the stairwell in the apartment, and I created this model. And I'm like, that's amazing. Oh, wait a second, it would be amazing if we actually if we connected that with IoT Hub, with Azure, and then put sensors around it, and then visualize the sensors in context of that model. And so this is a video of his model. I'm just going to show you really quickly here what this looks like. It's essentially using a device like this to capture a space, and this is something that you would have had to spend an amazing amount of time, before the folks at FARA, for example, were building this. So at lunch we said, well, you know what? There's this thing called Thingmonk happening. Why don't we create a digital twin of Thingmonk? Wouldn't that be cool? That's the theme of the conference. So let's do that. So I'm going to step off here for a second. Arturo's going to jump on, and then we'll do a demo right after that.
Thank you, Juan. Hey, everyone. Pleasure to be here with you. I particularly feel honored to be here as an architect, as a designer, not as an engineer, even though I know we have a broad set of disciplines here in the audience. So yeah, the story that Juan was sharing was an interesting one. I studied architecture, but left my practice 2 years after graduating, and since then I moved into doing user experience and user interface design, which is what I've been doing for all these years. But last year, I gave myself the opportunity to go back to architecture for the first time, and I took on my first architecture job, and it blew my mind away. I loved it again. I still love architecture, and I found it amazing how easy it is to translate user experience and user interface design concepts and processes to design architecture and design spaces. But as techies that we all are probably in this room, as soon as I jumped back into the real world, the physical world, the bricks, right, I started clashing with that world, right? Because I was used to what I like to call the immediacy of pixels. As a designer, if you want something to be blue, you make it blue, and it's blue, and it's done, and you ship it. If you want a button, you create a button, you drag and drop it into your UI, and it's a button, and that's it, right? So I was very spoiled by that immediacy of pixels. When I went into architecture, I came into this world where everything was slow and unpredictable, very hard to measure, you know, everything is really, really slow in the real world, right? So as part of our research, one of the things that came up in our list, in our exploration, was this scanner from a company called FARA. And David, are you here in the room by any chance already? No. We are supposed to have a visitor from FARA. So FARA is one of the many companies who does this kind of technology. This is a 3D scanner technology. What it does is it fires a laser beam that rotates 360 degrees, and depending on the quality of the laser, you're gonna get more or less points. This one, for example, captures up to 1 million points a second. So you can imagine the high density of points that it throws around our environment, and basically it captures our entire model. So I'm actually just gonna hit play button here so we can start scanning you all. So, and then we'll probably work together to make the scan available for you guys so you can download and play it. FARA actually offers a free reader that you can download to your computer, and then you can inspect and take a look at yourself and how you look in 3D. But what we do with this thing is we put it in spaces and we scan them. We can stitch them together, and we can create some of these really immersive point clouds, as they are called. The breakthrough for us in terms of this is that as an architect, whenever I'm encountered to modeling a place like this, imagine the amount of time it would take me or one of the people in my team to go and measure every single little thing. This thing, as you will see later on, measures everything, even the power outlets, like the little speck. It will see your eyes. It will capture your eyes as well. So it's very, very detailed. This really has enabled us to create sub-millimetrically accurate 3D models of any space like never before in a very easy way. So when talking to Juan, he introduced me to the concept of the digital twin, which I think I had only seen in that movie we were talking about yesterday, Apollo 13. I don't know if you wanted to bring that metaphor in, Juan, as well, but everyone has seen the movie, right? Apollo 13 with Tom Hanks. So if you guys remember, that was literally a rocket scientist type movie, right? Houston, we have a problem, we need help. What does Houston do? They call their top scientists and they say, okay, we kind of have this digital twin of this spaceship. Obviously back then everything was written or with punch cards or who knows, right? And somehow they managed to find the specific parts that these guys could use over there to save themselves. Now, with what Azure is bringing to the table, we can do that in a much different way. So my point with all of these, and one of the big takeaways for me, is that what Juan introduced us to as architects is really helping us totally break through in our careers as architects. We no longer have to think just in terms of a static space, but a space that is dynamic and that evolves with the use of sensors, as Juan is going to show us in just a moment. After scanning this place, we create a 3D model, which is what we're handing off to Juan, and he'll show you a little bit of some real magic, turning this static place into an actually dynamic with real data.
Thanks, Arturo.
Yeah,
so
thank you.
if you came to my workshop the other day, a couple days ago, it seems like 6 days ago for me, we played with these devices, and what I did with Arturo and his team is we created, like I said, a digital twin. So what I'm going to do is actually go to Unity. So how many people are familiar with Unity in the crowd? So Unity is a game development platform, and let me get out of this here. And surprisingly, it's not running. I thought I had it running. It's okay. And what I'll do is I'm going to connect, these are just simple batteries. These devices are the ones we played with. I'm going to plug them in, and I've pre-programmed them to actually use my phone's connection. Screen? Oh yeah, screen. Oh, that's me. Okay. And just to give you a high-level architecture perspective of what this is, these are the devices, the 3 devices. We have those devices are authenticating and communicating with IoT Hub, and they're sending messages to IoT Hub. I could have gone directly to Unity or to some other processor, but in this case I used Service Bus Message Queue to be able to use their HTTP interface, and I'm routing that data to the queue, and from Unity we're just pulling that out, right? We're just rendering it. So let me, so what you have here, what you're seeing is a model that Arturo and his team built before we came here. Usually what we would do is we would capture it, and then we would use that capture, but actually the folks from Shortage Studios already had some architectural information that they used. And what you're seeing here is basically 3 orbs that are currently, what it means that when they're using this effect is that they're not actually connected. So what I'm going to do is plug these guys in and have my Wi-Fi base station here ready to go. And I'm going to hand them to you, someone in the audience. And this device is connecting. So if you, I don't know if you want to help me here, but don't screw it up, okay? So it's connecting. This is proof. So it's connected to my phone, and there's a temperature sensor right here. Okay. So if you hold it like this, I'm going to tell you to actually put your finger on that, pretty hard, not too hard. And what you're going to do is you're going to warm that sensor. Because the pressure's on, it's your thing. If you screw this up, man, I'm telling you. So I'm going to connect from Unity, and what this is going to do, this is actually... I'm hot. You're hot? Yeah, I am. Okay.
I'm also humid.
To switch to C?
Let's see.
Not dead yet.
I think because I had to restart. Sorry?
I'm going to trust the data.
Let me see here. Okay, so we have some data flowing. Unity is not. Here we go. Let's see this. Who's an expert in Unity? There's a window on the right side that's supposed to be there.
Oh yeah, it could be, go to window, maybe something's closed on their window. Like, look for the properties, right? On their window.
Yeah, I'm looking for the property window here. Inspector, is that it? I think that's it. Let's see.
No.
Oh, that's it, yeah.
Yeah.
Oh, and I knew that was going to happen. So I was hoping this didn't happen because essentially, when it restarts, there's a bug that I have to re-import all my assets. It takes a second. Let me go.
Meantime, could we show the point cloud, maybe?
Sorry?
Should we show the point
Yeah,
cloud?
actually,
Meantime?
let's show the point cloud real quick that Arturo captured while we do this. And this should take just a couple minutes.
That way we can show something here.
James, it's your fault, man. You're holding it too hard.
So let me see if I can do this with with my mouse here. So this is one of the scans that we took just a moment ago. Not the very last one where you guys are all going to be captured. That one we're going to share a little bit later. But this is something that we captured just a moment ago. And let's take it here. So this is this room, actually. And we can kind of zoom in a little bit. And basically what you have here is just a bunch of points, millions of points. But once all of this is captured, it essentially creates a 3D model that's just made out of tons of little points, which is pretty wonderful. If I right-click over the scan that I took and I say locate scan, it's going to take me right into that scan, that particular scanner. And I can zoom out a little bit, and some of you guys will recognize each other there. See, there's someone. Now, we've all seen these 360-degree photos, right? Photo kind of tours. But the difference here is that this is not just a photo. These are actual semantic points. So if I say double-click here, I can navigate inside. So this information is so valuable, and that's, again, when I saw this as an architect, I was like, wow, this is what we need. So if I go into one of these areas, for example, and I go really deep, you will start noticing the points. Now, the point has no mass, right? So they are represented with these little kind of cubes, but that's really all they are. They're just little points. So let's switch back to Juan, right?
Yes,
Yep.
so it's working now. I re-imported. And the rest of the devices I'm connecting up. And these guys are logging in, and hopefully they'll connect to my Wi-Fi here. But what you're seeing is the data that is coming from James's device as the orb on the left side of the screen here. And then this data will be coming in here real quick. There's a really nice bug I had in my stuff that I couldn't get through last night. But yeah, this should actually work here. So once this connects, okay, so this guy's connected, and this guy is connected, and you start to see data. So what I have here is some code that basically has a few thresholds. If the temperature is less than 80, then it's green. If the temperature, this is device 2, let's see, if I hold my finger on it, it should, at some point here, send the data up to the cloud, and will render, the color will change. So there you go. So it started, and if I keep my finger on it, as it goes over 85, it'll turn red. And you're doing a really good job there, man. I mean, it's been red for some time. So thank you. So the other one's green. So this is essentially the point. Let me show you really quick from a developer's perspective, since there's a lot of developers here, what this looks like. So all I have to, if you look at this, there's not any rocket science here, right? This is just, if you look at inside the Unity code, there is, and that was the whole point, right? There are digital twins that are very complicated. But in order to kickstart this whole thing and really get momentum, let's show stuff that is simple so that everyone can get on the bandwagon, essentially. So all this is here is very hard to see. But if you look at this is just a web request to that queue in Service Bus. And that's the reason we use Service Bus, because it's really easy to use. And then we're grabbing that and then doing an if statement and seeing, hey, what device did this come from? And so the point is, it's pretty straightforward. But the other point is that I would have never been able to do this had we not had that lunch that day. And he posted that Facebook video, and then worked with one of his person on his team who's an expert in Unity. Obviously, I'm not an expert in Unity. That little thing that happened was just between us. And so this interdisciplinary team really came together to make this all happen. So any questions? Thank you so much for having us. And hopefully we can do it again. Yeah.
Thank you.